are back. Hello, everybody. Can you let me know in the comments if you can hear me, please? I don't think anybody joined yet. Let's wait a few more. Oh yeah. Thank you, Francisco, for letting me know you can hear me. Fantastic. Okay. So this week we'll continue to develop our Seagull game. As you can see, I am by myself for now. And we will have a very special guest soon, as soon as he gets back into the office, but it's going to be me for now. And we will continue developing our Seagull game. So last week we did the bumping your head on objects that are too big to eat logic, and Jermaine did some amazing job on our level, and today we will continue working on our game's UI. So we've already did some stuff on that aspect by creating variables that are going to store the Seagull size, the number of objects it has eaten, and today we're going to continue that work by creating the game's UI. So let me switch, and now you can see our screen, and let me just play it real quick. Let's see what's the current situation of our game. There you go, there's our Seagull. I'm flying, and I think I'm gonna change the position of the Seagull temporarily because Jermaine moved all the French fries to the other side of the level here by the diner. There they are. And see if I'm still being able to eat the fries. There you go. Fantastic. Everything is working. Let's see if the Seagull is increasing in size. Seagull scale. Where's our inspector? Size 1.5. Fantastic. We have pretty much everything we need to continue working on our game. So let me stop here, and I'm going to start. So as I said, we're going to make our UI, and to do that I'm going to start by right clicking on my hierarchy, selecting UI, text Mesh Pro, and I have to import text Mesh Pro into my project. Once that's done, Unity has created a canvas game object, which is massive, as you can see, and we already have this new text game object as well. So fantastic, we have our canvas, and the first thing I'm going to do in this canvas is my canvas have this component, canvas scaler, and one of the settings is the UI scale model. I'm going to change from constant pixel size to scale with screen size, because that way, let me just split my screen here so we can see both the text, both the game tab and the scene tab at the same time, because that way you're going to see that when we rescale our screen, the text is going to change accordingly. But before that, I'm going to position. Before that, let's change the aspect of our game to 16:9, so we have the same aspect that we would have on our monitor, right? Now I'm going to position this text game object. I'm going to put it here on the top left side of the screen, and then I'm going to anchor it to the top left side of my screen as well. So what anchor means is that our text is going to keep its relative position always based on the anchor. So by default, the object is anchored to the center of the screen, but maybe that's not exactly what we want, because depending on how our game screen changes, the text position may change as well. So I'm just going to anchor it to the top left side of the screen. And now, because our canvas is scaling with the screen size, as I reduce my screen size, you can see that the text size changes accordingly. So that is super easy to set up. And now on my text, I'm going to change a couple of things. So first of all, I'm going to change my text color to black just to make it easier to read. And I think the font size is a little bit too big. I'm going to change it to, let's say, 20. And this is going to be my my size, my Seagull size. So I'm going to write size 999 meters. So this is so I'm putting this very large number because I just want to check the size of my text field, and to ensure that the string is going to fit inside my text, to avoid line breaks like this. Since I don't see our Seagull getting this big, I think that's good enough. Next, I'm going to center it vertically, and I'm going to reduce my text size a little bit like this. Great. I'm going to rename this object to size text. Now, I'm going to duplicate this game object, move it a little bit below, like this. And this one is going to be the number of objects that the Seagull has eaten. So I'm going to write here, eaten, see? Line break. So, but again, removing the M from meters, I think that's good enough. And I'm going to call this one objects eaten text. Fantastic. In the meantime, if you have any questions, please let me know in the comments. Next, we're going to need two variables to feed information for this UI. So first of all, I need the Seagull size, which I already have, and I'm going to need an objects eaten variable, which I still don't have. I don't, right? Let me just double check here, because I'm not sure. I could have sworn I did it, but maybe I did it while I was rehearsing. So let's see here, increase Seagull size. But I don't, I really don't. So okay, great. So I'm going to create, so first of all, the size variable I already have on the Seagull here, right? It's the variable that we're changing when the Seagull eats something, but I also need an objects eaten variable, which I'm gonna keep here on my scene variables. I already have the glide variable, which controls if the Seagull is gliding or not. And I'm going to create a new one called objects eaten. Object eaten, there you go. I'm going to set its type to integer and its value to 0, because at the beginning of the game, the Seagull hasn't eaten any objects yet. And I'm going to create two more variables here, referencing the text fields I've just created. So I'm going to call one, oops, I need to give it a name first. I'm going to call it size text, and its type is going to be TM Pro, TextMesh Pro UGUI. TextMesh Pro is the component that renders the text in our scene, and the great advantage of TextMesh Pro when compared with the old text system for Unity is that TextMesh Pro uses vector graphics to write the font, so the font doesn't get blurry as you increase or decrease its size. So for the size text, I'm going to get my size text game object, drag it here, and now I'm going to create a objects eaten text of the type TextMesh Pro UGUI, game object, objects eaten text. Fantastic. So now I set up these variables, I'm doing the groundwork for updating my UI. So the next thing I'm going to do is I'm going to go into my God, this looks like a mess. I think at some point today I'm just going to do some house cleaning on this thing, depending on the time. But what I'm going to do now is I'm going to create a subgraph to avoid this getting more even more messier. I'm going to create a subgraph and I'm gonna call it update UI. So this subgraph will be responsible for redrawing our UI when needed, which is basically in 3 cases. Case number 1, when the game starts, I want to change this 9999999 to 1 meter and return to 0. Case number 2, when our Seagull eats something, then I'm going to increase its size, increase the number of objects eaten. And scenario number 3, when our Seagull tries to eat something that it's unable to eat, then it's going to decrease in size. So let's open update UI, and I'm gonna add one trigger input, which is just a way to get into these the subgraph, and an output, a way to leave it if we need. I'm not sure if we're gonna need to leave it, but let's, you know, better be safe than sorry. So just going to spread them a little bit, and now I'm going to need access to 4 variables here. First of all, get variable object, and I'm going to need the Seagull size. There you go. Next, I'm going, wait a minute. Oh, I already have an I knew I already had an object eating variable. It's right here on the Seagull. Great. So I don't need it. I don't need this one I just created. Get out of here. There you go. I knew it. Fantastic. Great. So I'm getting my size, and I'm gonna get my objects eaten, and also I need access to the two text fields I'm gonna have to update. So I'm gonna get a scene. I'm gonna get the size text and the objects eaten text. Great. So now I have my four variables that I'm going to be working with. So first thing I need to do is I'm going to call string format, and I'm going to format the string for my size, which should read size, and then an argument, which is going to be God, how was it? Is it 0.0? Okay, 0 to 0. I think it was hash. I think it was like this, meters. So this formatting here, this 0 before the semicolon means that I'm getting argument 0 and putting here in the string, and the 0 dot hash represents that I'm going to use a float and I want to use 2 decimal spaces. I'm going to feed my size as a parameter, and then I'm going to format another string, and this one is going to be my eaten string, and again it's going to receive argument 0. I don't need a semicolon hash on this one because it's an integer, so it's all good. So I'm going to get objects eaten, put here, and now I'm going to get my size text, and I'm going to call set text. I think it is this one. No, it's the Text Mesh Pro U GUI set text. I think it's this one. I think it is this one. Let's see. Text. Oh no, not this one. Replace set. I don't need an argument here. Although maybe I'm not gonna test it now, but maybe we can use it without an argument. Set text, and the source text is this guy here. No. God, it's not this one either. Ooh boy, we can make it. I know everybody here is patient, and you will allow my mistakes, right? Is this one? There you go. Yeah, that's the one. Brilliant. And now I'm gonna do the same. Oh, and I'm gonna do the same for the size text. So I'm going to get my object eaten text, and I'm gonna get my eaten format, put it here, and end. Great. So this is my update UI function, and I'm going to add a note here for the onStart event, and I'm gonna call my update UI function right at the beginning of my game. And I'm gonna leave these two nodes here, I'm gonna need them later. So now, if I run my game, it should update my size and eaten. Fingers crossed this is gonna work. I don't have Germain today, cross the fingers. Ah, there you go, it works, see? Now my size is 1 meter and I have eaten 0 objects. Fantastic, great. So our first scenario is done when the game starts. Now, scenario number 2, when the Seagull eats a game object, I need to update the UI to reflect its new size and the number of objects that's eaten. So when I quick recap, so what we do. So when the Seagull hits something on trigger enter, I verify if the object that the Seagull had touched has the string edible, has the tag edible, meaning that, well, it is edible. If it does, if true, I check if the object is smaller than the Seagull. If it is smaller than the Seagull, I increase the Seagull size, I destroy the game object, and I am updating the camera position, which pushes the camera back as the Seagull gets bigger. So what I'm going to do is I'm going to get this update UI subgraph, and I'm simply going to plug it between the destroy game object and the camera position. And to make things easier to test, I'm going to get my Seagull, move it all the way to the other side of my level. Don't need this anymore, we can do this, and I'm going to move my Seagull all the way to the other side of the level just to make it easier to test. I'm going to run my game, again, fingers crossed, let's see if it works. There's my Seagull, there are the fries, and hey, oh, yeah, of course, the size is working, 1.6 or 7.7, but what we are not doing yet is incrementing the objects eaten variable. So I'm going to go to my increase Seagull size. I'm going to get my object variable. Objects eaten, and I'm going to add 1 to it. There you go. And I'm going to call this set variable again. And I'm going to set objects eaten to this new value here. Let's move this over here. There you go. And now it should update objects eaten as well. There you go. And let's see. Fantastic. It is working. Let's start with the burger. There you go, 175 and eaten 7 objects. Seems to be working. Awesome. So, one last scenario missing, which is when the Seagull bonks its head on an object that is bigger than it is. And we no longer have we have the shark, right? So where is the shark? I think the shark, here's the Seagull, and the shark check. The shark's over here. And does a shark have a collider? And the shark size is 8. So let's just give it a try. Let's see what happens if I try to eat the shark right now. It should, again, the seagull should bonk its head and not able to eat the shark. Let's see. Ah, there you go. It's working. Fantastic. Ooh, what happened there? Let's see. There you go. Awesome. So what I'm going to do is exactly the same thing. Let's go back to my logic when the seagull tries to eat something. And again, we're going to clear this up. So if the object is smaller, if the object is not smaller, so if we go to the false root, we're going to apply the force to the seagull and decrease the seagull size, play the particle system. So let's put it right here. We had another one. There you go. I'm going to do update UI right here. And let's see if that's going to work. I think I noticed a tiny bug when the seagull is hitting the shark. I'm not going to worry about it right now, but I think the force applied is always in the same direction, but we're going to fix that. So I hit the shark and my size reduced to 0.9. Let's try again. 0.81. And I want to show something cool, is that our size right now is 0.809999. But since I'm only showing 2 decimal places on my screen, I'm seeing 0.81. So this is exactly to avoid showing 0.809999, which, you know, it would look weird. So I know that my size now is 0.81. Let's try to eat something to see if it is gonna work. There's our, you guys remember our chicken driving the tractor, right? And it's working, see? 1.11, 21, 31. Great, fantastic. So our canvas is pretty much done. It's pretty straightforward. Of course, we could tinker with font size and the type of font. I'm just using Unity's standard font, which I don't think it applies to this game. We should use a cooler font, but that's, you know, that's tinkering and trying to improve on our UI. But in terms of UI, we're pretty much done. So what I'm going to do now, since we have plenty of time, we're just 25 minutes into the stream. So what I'm going to do now is I'm going to try to clear this a little bit up, because, I mean, this part here, when we're increasing the seagull size, it is pretty neat. I mean, what we could do here is say on this increased seagull size, I could add another data input here called object, which is the object that we've eaten of the type, I think it was game object. There you go. And then object eaten. There you go. And then going back, I passed the game object as a parameter here, and I move this destroy inside the subgraph, and that's going to clear up another node on our main graph. So we remove this game object destroy node for now, go straight to update UI. Let's just give a quick test here and see if that's working fine. Just make sure you haven't broken anything. There are the French fries. Yeah, it's working. So, you know, we cleared it up a little bit more. That's great. It is working, right? Yeah. The fries are gone. Let's stop running. Cool. So I can remove this node here. It's a little bit cleaner now, but the false path here, when I try to eat an object that is bigger than I am, it is a mess. I mean, this is horrible. So let's try to clear this up a little bit. How about that? So we already have the subgraph here, decrease Seagull size. That's doing a whole bunch of things. Maybe, you know what I'm going to do? I'm going to create a new one called, let's create a subgraph here, called pushback Seagull. Great. And that's going to have start input, an end input, and it's going to have one, no, it doesn't need a, because you can get this variable inside of it. Yeah, so let's get these 3 nodes. I'm going to copy and paste them within my subgraph. There you go. And I'm going to go back here and I'm going to disconnect these 3. That's, I'm not going to delete them for now. I'm just going to move them. God. Just going to move them here for a while. Pushback Seagull. False. Node, node. There you go. Let's bring all these guys back here. Okay, so let's see if that is working. I'm gonna press play and fly here and let's bonk our heads. Oh, it didn't work. There's something wrong. Oh, okay. Oh, okay. So the pushback force variable, it exists on the parent graph, but doesn't exist on the parent subgraph. So that's okay. What I'm going to do is I'm going to create a pushback force variable here of the type float, value 20, and that should do it. And I don't need this pushback force variable in the parent graph anymore. So let's press play and let's see how it goes. Hey, look at that. It worked. Fantastic. It is better. Maybe I'm going to I'm gonna get this particle system. I got these 2 nodes. I'm gonna copy them. Maybe I can put them on the decrease Seagull size before I check for the game over condition. So I'm gonna paste them here, and I go this way and this way. Let's just put it here, and then I don't play my particle system here. Just leave it down here for now. Go to update UI. Let's see if that works. In the meantime, if you have any questions, any comments, any ideas, just feel free to send them on chat. We are very quiet today. I hope you guys are not sleeping. I know that Jermaine is the big star, but sadly he can't be here with us today. See, it's working. Great. So there you go. Our particle system is working. So decrease Seagull size, update UI, and so I can remove these guys here. We can remove these guys here, and you know, it's better. It's inevitable that your visual scripting may look a bit messy as it grows bigger and bigger, but you know, it's sure it's better than it was before, you know. And here we have the enable and disable input. This one we're gonna have to keep here, and yeah, cool. So this is what we had to present today. I was planning on doing the UI, and we did the UI, and we cleaned up. Let me have a look. Let me see if there's something else that we can clean up here. This, you know something I hate about visual scripting is always ifs are always ugly. You know, it's like ifs are one line of code when you're coding, and they are this jumbled mess of visual scripting. So it always annoyed me, but there's really, I guess there's really no way around it, and you know, it's just a fact of life. Push back Seagull, decrease Seagull size. No, I guess that's it. I guess there's not a whole bunch more we can do in terms of cleaning this one up. Let's see the other graphs. So this one is the which one is this again? This one is the where's the name? Jeez, what is the name of the I think this one is the movement. Yeah, this one is the movement controller. I don't think there's a lot we can do here. On update, we check if input is enabled. If it is, we check glide. If I'm gliding, yeah, no, we had this ugly thing here. Let's delete this. And then we already have a subgraph here, which is move Seagull, and that one is fine. Yeah, so I think this one is okay. Let's see the movement control of the rotation controller. Yeah, I think that one's okay. So I don't think there's a lot we can improve here. We could. Let me get back to the foot collision. So we have an issue here that I noticed that when I hit my head on the shark, if I come from this side here, you're gonna notice that the Seagull is pushed sideways. See, not backwards, and that's because I'm applying the force on the x-axis of the Seagull, which is the if we look at the global at the global coordinates, the x-axis is the one going in the same way as the street. So that's why it's being pushed sideways. So the right thing to do would be to push and just play again. And I'm just going to move the Seagull right here. And let's have a look at the Seagull. And the right way to push it would be in our local z-axis behind, and I need to figure out how to do that. I wonder if there's any end force that I can define. Using the local rotation. I'm going to come here on my second screen. I'm going to quickly Google how to add force using local rotation. This is what happens when you try to do things live that you haven't rehearsed before. It's like Oh, okay. So, and relative force. Let's try this one. And I'm going to just connect this here for a while. Just gonna move this here, and I'm gonna create a new vector. No, just a vector. But I'm going to apply the force in the z-axis, but times -1. Multiply this by integer literal -1. There you go. And to the z-axis, we created the vector tree, and we're going to apply this force, mode impulse, and let's see if that works. Drum roll, and hey, look at that, it worked. And now let's try from the other side. Let's see if it's still working. Ha! Amazing! It worked. We fixed it. Great. I'm so happy now. I always hate these bugs, especially when they linger. I would be mad if I kept that until the next stream. Oh, great. We fixed that. I'm happy now. Cool. Great. So we are approaching 40 minutes. And as I said, what I had planned today was that, and my special guests have abandoned me. So I believe that we are going to wrap up today with our UI and our cleanup and our bug fixing. And as usual, this will be this project will be shared on Bitbucket. We'll share the link on our Anything World channels on LinkedIn and Twitter. And please download the project, play around with it, and if you make something cool, let us know. We always love to hear about what you are doing. And with that, I thank you all very much and see you on the next stream.